Alright, in this video we're going to introduce ellipses, and we're going to identify the center, vertices, and foci of an ellipse. So an ellipse is a set of points in the plane such that the sum of their distances from two fixed points called foci is constant. So in other words, if we take these two focal points, these foci, and we pick a point on the ellipse, that means that this distance 1 plus this distance 2 is going to be the same number, same value, no matter where on this ellipse we are. To make these, drawing them out, if you took a piece of string and tacked it onto, let's say, a cork board, and real taut between these two focal points, and then if you took a pen or pencil and tried to draw a circle, you would end up with this ellipse shape. So ellipses are typically going to appear either wide or tall, wider or taller, based on their equation. So here we have, I'm sorry, this got cut off a little bit. Here we have an ellipse that's wider than it is tall. So we have the center of an ellipse, much like we have the center of a circle, and the width of the ellipse is called the major axis, and that's what got cut off down here. It's called the major axis. So the distance from one endpoint on the wide axis to the other is called the major axis. Those endpoints are called vertices, so each one's a vertex. Our focus points were those 2 points that were inside in the previous example. They sit on the major axis, and the distance from the center to the focus going to the left is going to be the same as the distance from the center to the focus going to the right. And same thing with the distance from the center to this vertex is going to be the same as the distance from the center to this vertex. The axis that goes through the center that's perpendicular to the major axis is called the minor axis, and the major axis for an ellipse will always be longer than the minor axis will. And the endpoints of the minor axis, where the minor axis hits the ellipse, they're called co-vertices, and the distance from the center to this co-vertex is the same as the distance from the center to this co-vertex. For ellipses that are taller, the major axis now is going up and down, so it's stretching it more vertically than horizontally. But notice again, the focal points, the focus and the focus here, and the vertices both lie on the major axis. The minor axis this time, still perpendicular to the major, but now the minor axis is horizontal, and the endpoints here are called, again, the co-vertices. Now, as far as the center of an ellipse, much like the center of a circle and the vertex of a parabola, but the center of a circle and the center of an ellipse both use H and K, so that's a little bit of familiarity with what we've talked about before. In fact, you can think of an ellipse as somewhat of a warped or distorted circle, where instead of the distance being the same from the center to every point on the edge, some spots it's wider than others. So each focal point, with the plural of that is foci, is going to be c units from the center. So we use c as the distance from the center to a focus, or either one of the foci. The foci, again, are always going to lie on the major axis. So each vertex, in the plural again is vertices, also lies on the major axis and is going to be a units away from the center. So we call the distance from the center to a vertex, we call that a. And each co-vertex, or the plural is co-vertices, is going to lie on the minor axis, which is always perpendicular to the major axis. And the co-vertices are each going to be b units away from the center. So the distance from the center to one of the co-vertices is going to be the value of b. So putting it all together, and it looks rather intimidating, I understand that. A represents the distance from the center to a vertice. So we have distance from A and A. B represents distance from the center to the co-vertice, or co-vertex. And then C is the distance from the center to the focal point. Now, I would not recommend memorizing all these different H's and K's, pluses and minuses, and all that stuff. I strongly urge to graph as much as you possibly can and work with your graphing and your sketching. But just keep in mind that A is the distance from the center to a vertex, B is the distance from the center to a co-vertex, C is the distance from the center to a focal point or focus, and you'll be okay. So our equation that has an ellipse that's wide is going to be x minus h in parentheses squared over a squared plus y minus k in parentheses squared over b squared equals 1. So we still have the x minus h squared and y minus k squared that we had for circles, but this time instead of it equaling r squared, it's going to equal 1, which means for a lot of cases of ellipses, we have something below the x minus h squared or something below the y minus k squared. And if it's a wide ellipse, the value of a is always going to be bigger than b. So for wide ellipses, the larger number will be below your x variable. So it's a good way to kind of help you remember the equation. For ellipses that are taller, nothing's really changed as far as the diagram goes. The variables a, b, and c still represent what they did before. It's just now the bigger number will be below the y instead of the x. So if a is longer than b, then a squared has to be bigger than b squared. So here we have for a tall ellipse, an ellipse that's taller than it is wide, y minus k in parentheses squared over a squared plus x minus h in parentheses squared over b squared equals 1. So note in both cases the value of c, or in this case c squared, is going to be a squared minus b squared. So it's a little bit like the Pythagorean theorem, but instead of a squared plus b squared, your distance from your center to your focus point, that value of c, when you square it, is a squared minus b squared. And a is always going to be bigger than b. Not always going to be the case for hyperbolas, which we'll talk about in another video. Find the center, the lines containing the major and minor axes, the vertices, the endpoints of the minor axis, also known as the co-vertices, and the foci for the ellipse with the following equation. X plus 1 in parentheses squared over 9 plus y minus 2 in parentheses squared over 25 equals 1. All right, well, first and foremost, I strongly urge you to graph it if you can. A lot of technology now allows you to graph things rather easily. Here's what it looks like. Our center is x has a plus 1 and y has a minus 2 afterwards, so it's negative 1 and 2 is our center. So there's our center. Our vertices, a squared is always the bigger denominator, so a squared is equal to 25, which means a is positive and negative 5, positive or negative 5. So what that means is from our center, we'd have to count up 5 units to get one vertex and down 5 units to get another. And we're going up and down again because the bigger denominator is below the y. So that means it's going to be a tall ellipse and not a wide ellipse. So when we do that, we have negative 1, and then we're going to take the y-coordinate of 2, add and subtract 5 to it, which we can combine those like terms. So we get vertices at negative 1, 7, and negative 1, negative 3. Our major axis line is going to connect those vertices, and if our major axis line is a vertical line, it's x equals wherever it hits the x-axis, which in this case is negative 1. Our co-vertices, we're going to find the value of b, but b squared equals 9 means b is plus or minus 3, so we're going to count 3 to the right, 3 to the left from our center. So that's going to add and subtract 3 from the x-coordinate of our center, which, again, if you plot these and get a graph of them, makes it a lot easier to visualize it than to try to do everything numerically. But that's going to give us co-vertices at negative 4, 2 and positive 2, 2. Our minor axis is going to connect those co-vertices, and we have a horizontal line going through 2 on the y-axis. So our minor axis line is y equals 2. Now for our focal points, our foci, those are going to be, in this case, because it's a tall ellipse, those are going to be above, c units above and c units below our center. And to get the value of c, we have to take a squared minus b squared. So a squared is 25, b squared is 9, 25 minus 9 is 16. And when we take the square root of 16, we get plus or minus 4. So we're going to count up 4 from our center and down 4 from our center. and that's going to make our coordinates of our foci at -1, -2, and -1 and 6. So those are our foci. So again, I strongly encourage you to graph it as soon as you can. Use the technology that you have available, and then from there start dissecting it by finding the center, vertices, etc. So, all right, that about does it for this video. Thank you for watching, and I'll see you next time.